My usual image, you can say that's my color image actually. Now I'll try to make some necessary changes here. First change will be that, which will be pretty common, and that will be we need to convert RGB image to grayscale. This does look like a start with my grayscale here. Convert RGB image to grayscale. We start with img underscore g. Grayscale equals to cv2.cvt color. Here my image data, and we need to convert it into by the help of cv2.color underscore vgr to gray. Okay, we got here my grayscale image with my print image underscore g. When I'll print here my image, this is gonna display the array with the image value. Whereas if I'll print image underscore g, it will print all my grayscale images value. To display it, I'll use the same thing, but I need to write here the frame number, okay, to 2. We have to just change the frame name. It could be anything, and we have to write the file name. Sorry, we have to write the variable name where we have read your image. Read images are stored under this, which will be obviously stored in an 3D array form, or you can say you can just run it now. Instead, let's just press escape. Now execute it, and you will be able to observe two different images, which is at the bottom. We've got here my color frame, and we have got here my grayscale image. Two different forms of the images are displayed. This is how you can make the changes with the help of convert color. CVT color is to convert the color of the existing image. Now next is hue saturation value. This is the first convert. Third convert will be convert RGB image. Hue saturation value starts with my hue, sorry, HSV. We pick here my image underscore HSV. We will provide here my color image, and we will convert here BGR to HSV. Image underscore HSV will be printed here, and we'll put here my frame 3 to get my outputs. This means that wait for any key to press and destroy all the windows means close all frames. Whenever you will press any keyword, any keypad button, it will automatically get closed. Like if I'll open it and I'll press escape button, you can see that it has destroyed all the opened windows. Let me click on play button. Now you will see three things. This is your HSV, hue saturation value, and this is your grayscale, which does look like a gray, which does look like a black and white. But remember, black and white is a three-dimensional image, and hue saturation value is a two-dimensional. This is your regular RGB image. Okay, one more thing I need to talk about here. Please remember one thing, that OpenCV reads image as BGR, that is blue, green, red. Score basic first file. My first file is saved. Click on file. Click on new. First example is over. I'll start with the second one. Speed up, guys. We are going very slow. This is not this does not worth half an hour. Okay, next example. OpenCV basic 2. That's my next file. In the next file, we will try to find the edges of the image. To get the edges of the image, we can use here what you will say the packages of OpenCV again. And under that, we are having something called as canny. So we need to use canny to get those results. So these are all your image processing going on. Okay, that my original image will be converted to different things. So as I said, like I will particularly try to now display here the edge detection we will be doing. This is your basic part number 2, in which we will try to do edge detection, image gradients. This is one of the fundamental techniques, so that's why we can put it under we can do it with the help of canny. I'll try to read first the packages. See, basic step remains same, import cv2, and because you are working on images, so you need to wait for any key, and it will destroy all the windows. Let's try to read the image data. To do that, we will be using here cv2 I am read and I need to read the image. The image that we can take in this example that we can take will be good. Okay, let me upload one more image. I think we need some other images here. I'm uploading one male image and one girl image. You can choose accordingly any one of these two options. Girl.jpg is uploaded and male.jpg is also uploaded in the same Google Drive. It start with E, opencv, and we can take here with girl.jpg. We have taken this girl.jpg image. Let's try to convert this into a grayscale image first. Convert image to grayscale. Remember that here the image is BGR. Convert image BGR. BGR form in this form your images are read into the grayscale image. Take here gray equals to cv2 dot cvt color. Convert color. We start with image cv2 dot color underscore bgr to gray font. This is exactly what we have done earlier as well, and we can display these two images. Again, somebody's mic is on. We start with my original frame. Then we start with cv2.imshow with my frame 2, and this will be displaying my gray font. Okay, this is how my images look like. If I wanted to print like what is the shape of the image, so I can write here gray, that is your image name dot shape to display the shape of the image. Okay, so one thing you can observe that your image is not properly fit. This is the shape of the image, which is the resolution. It shows that the shape is 940 cross 626. If in case your image is not properly fitted, we can reduce the shape of the image or size of the image. Okay, so to do that one, we will wait for it. But before that, just try to convert everything here, and what we will do is we will try to detect the edges. Start with my edges equals to cv2.canny. The shape is 100 cross 255. Okay, what are we fitting in this case? What does the canny take? Canny takes some threshold points. cv2 dot canny is there. In this, three parameters will be taken. First will be image, second will be the threshold value 1, and second is your threshold value 2. Using these threshold values, we will try to compute here. Computing the edge gradient will be calculated using or with canny thresholds. It goes like edges equals to cv2 dot canny. Pass here gray, and we have got the minimum value and the maximum value, which is 100 cross 255. Threshold value you can set between anything from 0 to 255 value, and according to the thresholds your edge gradient will be computed, and according to the edge gradient your edges will be detected. Let me show you the result. Again, cv2.imshow, and I need to change here the frame to frame 3. Let's replace the image by edges. Okay, this is how your edges are detected. This looks to be pretty high as compared to the image. If you will see, uh, our edges are not even detected properly. The face and hair is fine, but the shoulders are not there. The hand is also not visible properly. So maybe we need to go for a lower value. So we can reduce this, the high threshold. Maybe we can reduce it to say 200 and some 200 or something. Further, we need to reduce. We'll go for say 80 minimum. Maximum we can go for let's say 230. Okay, now the edges are pretty much visible to us. This is how you can try to get the edges. To detect the edges, you can use scan. This is your OpenCV basic part number 2.
Sir, I couldn't get that help. Can you please type that how to get the help to see what are the functions available like that?
CV, just write that and press tab. No, told you
CV2
already.
dot.
CV2 dot, let's say CV2 dot destroy Windows is there. I will write DES and I press tab and it will automatically come. It's
Yeah.
coming.
Okay, sir. Thank you. Yeah, I'll check it out, sir.
It is done by Canny. Next, it can be done by one more thing called as. So one is like the Canny part where need to write here threshold 1 and threshold 2. Okay, now how does it works? Please remember here we have got a minimum threshold and we have got the maximum threshold value. So let's start with so here we go. So there are two values here, threshold value number one, threshold value number two. Remember that here gradient that are, so a gradient will be calculated for with the help of, or you can say that edge gradient will be calculated on the basis of these two, minimum threshold and your maximum threshold value. So the gradients, or you can say the edge gradient that are greater than threshold value number two, they will be considered as, and there is a minimum threshold as well, which we have taken as 80 or something. So what happens is, once they have calculated the edge gradient that are below than threshold one, they will be considered as not edges. So basically, whatever the value you mention here, please remember that this should be the minimum value and this should be a very maximum value. Okay, whatever you can write, and this number can be anything between 0 to 255. That's what that's, and accordingly your edge will be detected. Now you can see that we have taken a very low value for the maximum threshold, so more edges are highlighted. Try to change the things accordingly. If I'll further below,
Hello.
more edges will be calculated, more edges will be found. Let me add these additional details to your file so that you all can also copy and
Sir, it is showing no module found CV2. No module named
try
CV2. So what?
on. Did you install yesterday?
Yes, yes,
OpenCV,
I
did you
installed it, sir.
install?
Yeah, yeah, yeah. Yes, I
Try on
installed.
Jupyter. Hopefully, it is completed for everyone. And this is how my basic part, basic second part is completed here. Let me try one more options here. Like we can try with some Laplacian value, or you can try with Sobel as well. Canny, I find it much more easier to implement, and the edges are detected quite nicely. So that's the reason why I do it with the help of this. We have one more option called as Sobel that I like to show you. In order to apply the Sobel part to perform the edge detection again, this is another method we have, Sobel, just like the way we have got Canny, similar to that. In this, first of all, we need to convert the image from BGR. As I told you earlier, remember one thing, that your image is read as a BGR form. If you wanted to convert this BGR to RGB, this is how you will be doing. So convert your image, and in this you will write here BGR to RGB. Let's save this as image. Then we'll start with the. So we just converted here the image color. Let's get the height of the image and width of the image, and some miscellaneous value will also come, which will be like the dimensionality and all. That's not important. We got the image, and so image shape will return me three things. Image shape will return me height and width. Apply Sobel edges. X underscore Sobel. Let's get the X Sobel first with the help of cb2 dot Sobel. So what exactly the Sobel is? You can see that here are the details. When you write the function, automatically this dialog box opens up. It is taking your source, that image, then depth, uh, dx, dy, etc. details are there, and it will basically try to find the edges. Source will be img1. Then we need to take here the depth will be given by cv2 dot cv underscore 64f01. That's your starting value, and then we need the kernel size, k size, which will be equals to, let's say I'll go for 5. You can take any odd number in place of k size. Next is y underscore Sobel. This will take here again image. Rest all remain same. Yeah, here just we will change it to 10, and k size will remain 5. This is for y Sobel. This is for x Sobel. And now I need to use this Sobel value to particularly apply on different images and get the outputs. So to print the x Sobel value, you will write simply cv2 dot imshow. I'll name it as Sobel 1 or Sobel underscore x. You have to write like this. Next is Sobel underscore y. You can mention here y underscore Sobel. Now run it. Okay, that's the difference. between Canny and Sobel. This is how your Sobel works. Again, it is detecting the edges, and this is your Canny result. So again, these are all part of data pre-processing, and it is subject to your requirement. And this can be modified according to your requirements and according to the type of threshold that you will be needed to pre-process your. As I told you, there are other options as well, like Laplacian value, bitwise is also there. So you can try them to detect your edges. Let's go with my next option. In the basic 3, I will apply how to basically apply smoothing of the image, or you can also call it as how to add blur to your images. So we'll try to do that blur or smoothing part.
So can once again tell me that what is cv2.cv under 64f that in Sobel?
This was your DD. In filter 2 also we need to use that DD depth. Let me discuss about that. I'm hoping that you understand what is the meaning of this F means 64 float value. This is like 64 size. F is floating term. Similarly, you can write 8F, 16F, 32F, 64F. Okay. And what is DD depth? D depth, which will be equals to a desired depth. So this is a type of, this is just a data type you have to mention. In the next example, we need to mention the DD depth according to our requirements. So let's get started with the next, as we all have confirmed that you have finished. This will be your basic part number 3, import CV2. In this, NumPy, yeah, NumPy will be used. So import NumPy as NP. Let's read an image data. Instead, let's read the same girl image. Okay, we got here my image data. Now on this, we need to apply the smoothing. This is basically known as a smoothing of image using kernel metric. We start with kernel equals to np dot ones with a shape of 5 cross 5 with a floating value of np dot float divided by 25. Okay, basically we are trying to create a kernel matrix. Kernel is okay. Now let me give you a quick explanation of what exactly we are. Use this image, and when you will read it, you are gonna get a resultant matrix. This is my first matrix data. Now let's pick another matrix. Similarly, we'll have red is there. Similarly, we'll have the green and blue as well. Just to give you the explanation, remember that this is my matrix data that we have got. Okay. So what happens is that to transform this image into a new resultant image data, I will basically perform a dot product with another matrix which will be basically given by us. Obviously, it will be comparatively very small shape because original images will be always very large shape image. Okay, and this is how your kernel will be computed. Okay, it will be a small matrix which will basically perform an element by element matrix multiplication with both of these, and the resultant matrix will be your smooth, or you can also call it as blur. Where it is used, application, this is my matrix multiplication. You can have a shape of, let's say, 100 cross 100. This will be always of odd shape. That means the desired shape could be 3 cross 3. From the original image, matrix will be calculated. This is my original image, and from the original image your matrices are calculated, and from this matrices there will be a kernel matrix which will basically place itself over this matrix. Imagine that it will be placed like this, and it will perform the element by element multiplication. And once it has performed the multiplication, it will result into a desired or a smoothed. That was the quick explanation. Rest all we will talk about the kernel matrix when we will discuss about the topic of convolution neural network. Okay, let's do it. So I just created a kernel matrix, which is basically a one matrix of shape 5 cross 5, and it is divided by 25. I'll create one more kernel here. You can also create a kernel like this, which will be an np.array, and we can write here values. Okay, you can write any number between Okay, you can write any number here. Let's say I'll go with -1, -1, -1, and again more matrix as -1, comma 9, comma -1, and -1, comma -1, comma -1, like this. We have created a kernel array. Okay, let's sharp our images by the help of cv2.filter. Pass the image with img, comma -1, comma kernel sharpening. I'll provide here the kernel value. DD depth is -1. -1 means as per the previous value. That is what it means. When you write -1 means as per your desired depth. Filter 2D as per the default value. Write -1. Otherwise, you can write this type of number as we have written here. Okay, moving ahead. So filter 2D takes three parameter. First parameter is your source. Second parameter is your DD depth, which is basically your desired depth of the image. And third is your kernel matrix. Now the kernel matrix you can create either with the help of this way. Remember that this divisible factor will change according to the shape. Like if it will be 3 cross 3, then you need to divide it by 9. So accordingly your kernel will definitely kernel value will change and accordingly your blur will also change. The first one will take img as a value and second one will take your desired result from here. Maybe you can save it as smoothed. Okay, so here we go. We start with my filter 2D. Anyway, we have not used the kernel one as of now. Let's use it. Okay, this is your original image. This is your blur image. You can see there is no large blur option you can see. Let's try to add a higher blur. So I'll change this to 5 cross 5 divided by 25. Let's play this. So now this is a little more blur, a higher blur value. Let's say this is a smoothed one, and let's replace kernel by kernel underscore one. We'll go with my filtered. Uh, Maybe I'll just name it as frame one, and let's replace this by. Can be anything. Smoothed one. Let's see what the third image generates. The third image is basically a resultant of the first two. Before that, you need to press escape button and remove everything. So here we go. This is what your first original image is. This is your smoothed result, which is basically as a smoothed everything, and this is your blur output. So you can understand it like how basically the image transformations can take place. This is your smoothing, this is your blur. All are done by the method of. So this is majorly like sharpening. To sharpen, this is the way you will develop your kernels. If you want that, okay, no, this is too large for me, so what you can do is you can change the shape to, let's say, 5 cross 5 maybe. Right now, sorry, not 5 cross 5, what we can have 9. This should be the minimum, I guess, because the center element will be the. Okay, maybe I'll just try to change it to 5. Let's see, because I can take an odd number. We press escape button. Let's see the smoothing now. Okay, I think no. So this is your, maybe we can write here sharpening, sharpen image. This is your blur image. So we maybe can write it as blur one. Okay, so do it parallelly. You have already taken the values. Just updated it. Next option parallelly. So let me finish this and then you can try them all together. I will try now Gaussian blur. Gaussian blur. I'll write here g underscore blur equals to cv2 dot Gaussian blur. Source is image. Kernel shape. Take any number, odd number. 9 cross 9. Sigma s is a standard deviation. I'll go for 0. Standard deviation as 1. Kernel shape must be odd positive value. So it could be 3 cross 3, 5 cross 5, 7 cross 7, etc. Sigma x is your standard deviation. Sharpen 1, or we can say here we can write Gaussian blur, G underscore blur. Next, Gaussian blur. After that, we have got another one which is median blur. As the name suggests, Gaussian will calculate the Gaussian value. Median will calculate the median value from the image numbers. In the median, you have to just provide an individual value, like again odd number it has to be, but only individual, because the shape will be always of a square shape. So you can take like 11, 12. So under so in Gaussian blur, Gaussian value will be calculated, whereas in median blur, median value will be selected. So median pixel values under selected shape, and if you don't know the median, it is basically the central element or central value selected 11 pixel values. So this is how it will take. It will take first 11 value, it will find its central value, then again next 11, then next 11, and so on. Like that, it will calculate the median blur, and from the median blur, it will return me the resultant value. Maybe you can write here m underscore blur. Now let's execute it. You will see this is your sharpen image. This is your blur. This is average blur, and this is Gaussian blur, and this is median blur. Median blur look like a picture. If you think that these blur are quite high for you, you can change these numbers to another lower odd possible value. Like 11 can be changed to the next odd value, which could be 9, and this can be changed to 9 cross 9. Again, if I'll run it, sorry, before I run, destroy all the windows and execute it again. Now you can see that with the lower value of blur, things are different. This is how it appears altogether, different blur options. Okay, so this was your basic. Again, this will be quite useful in preparation of the image, especially in removing the noise from the image data.
Every time while the image it is reading and showing, my system is showing it is not responding. So any problem with it?
Just press escape button to close all the windows in spite of using close, or press any button, in fact, like this. When I start, it opens all the window, and then I press Q or something, so it destroy everything. This line is important in the end of everything.
Sir, 1 second, I could not get it.
Hello?
1 second, I could not get. Can you explain 1 second? I could not get it perfectly.
Oh, I said that this line is important to finish everything closely.
Okay.
So play button and press escape. Okay, once we are done here, you can see that we are having the options coming up, and through that you can provide all the details. You can just run a play button, and you will see here all the results, which starts with, after getting the blur and all, we will go for let's prepare a noisy image. Okay, we will add some salt and pepper to our images, and that's basically to generate a noisy image, and then we will see the application of these blur options. Okay, so let's begin with the new file. Before noise underscore, so the noise which I'm trying to generate is called as black, what you will say, salt and pepper. This will be basic like black and white. I'll create a function simple, and I'll pass here the image as a parameter. Get the row, get the column, and we will write here image.shape. So
random
image
is a
dot,
package. Excuse me.
huh?
Is random is a
Random
package?
is a package. Random
Okay.
is a package. We got here rows and columns, and the rows and columns are basically the dimensionality of the image. So basically, we'll get the dimensionality here. Get the dimension. Number of pixels equals to random dot random integer, and I wanted to generate here some random integer values. Let's take some number between 1500 to some 20,000 value. This is number of pixels. Okay, number of pixels are there, so definitely it should be lower than the multiplication of rows and columns, because the total number of pixel. In fact, dimensionality will be also there. So number of pixels in rows, number of pixels in columns, and dimensionality. If you will multiply all three, you will get the total number of pixels. So the range should be within the limit of rows and columns multiplication value, and it will randomly be picked. So randomly pick pixel values in image. Okay, now let's fill them with black color and white color pixels for all these pixels value. Let's start with that for I in range, and we start with the number of pixels. Random y coordinate, y underscore coordinate is equals to random dot random integer, starts with 0, ends with row minus 1. Got here my y coordinate, we got here my x coordinate. Let's start with my color random color pixels with white color. We start with my image with y underscore coordinate, and at the same time we will take here x underscore coordinate. Okay, the positions, basically these are your pixel positions where we will fill it with white color. So what will be the color for white? 255. This function is basically gonna iterate through the total number of random pixels that has been selected here, which will be, let's say, 10,000 something. So for all those 10,000, it will iterate, and it will find the x coordinate and y coordinate numbers with the help of a random integer function. Random is to select basically the random positions. So random pixel positions will be filled with 255, and 255 is nothing but it is basically your white color. Now we need to repeat the same for the black color as well, and this is how your salt and pepper noisy image will be generated, or you can say black and white noise will be added to your images. In the second part, you have to just replace the color, which will be replaced to 0 because it is random. So your okay, let's run it again. Random integer, because the position should not remain same. Okay, here we go. So again we have chosen some random pixels between this, and so we'll not have the same number, and this is how a normal basic function will be returning an image. So input will be an image, normal image, and return image will be a noisy image. This image needs to be saved somewhere so that later this can be used for data pre-processing. We'll start with image equals to cv2.imread. I'll start with parrot.jpg, and to that, I'll read this image as a grayscale. Directly we can apply. Again, options are there. You can press tab to get the options like this, cv2.imread. Okay, multiple options are there. Out of that, grayscale we have to choose. Just choose the grayscale as an option. No need to pass it as a function. And now to that, I will be converting everything into a new show, cv2 dot I am show. Take here my original image. Okay, let's check how your images are created, and then we will save it. This is the resultant image. This is the input image, which is basically read as a grayscale. And to grayscale, adding salt and pepper is quite good. Every time you will execute it, the images will definitely change. Remember it. It won't be same. Why? Because it's random. Now save this somewhere permanently. First of all, you try this whole thing, and if you have got any questions, you can. This was the breakdown of a image. You can name this file as opencv underscore noise. Basically, this is the method. This is the way to generate a noisy image with the help of your function named as noise underscore black and white.
Underscore grayscale, is it that need to be write in capital or?
This is predefined. No, this now I showed you. Look at here. When you write cv2 dot, and obviously you have to write some initial and press tab. So it will, when you write tab, you will see the options. Okay, you have to write according to that. You cannot modify it. This should be all in capital.
Tab, once I put it, is the cursor is going out, going one space.
Sorry.
So I'm not able to get that options now. That is how it is. Imread after
Dot
that.
and tab. Dot and tab. You write dot and you write some initial like I am read, okay, and then press tab. Automatically it will come. If it is not coming, then try on Jupyter Notebook. There it will come.
Here, this randint always changes in the range of
Yeah.
1500 to 20,000, right?
Yeah, correct.
Okay, means it can be it is not like we were doing like in the array, that is similar to array, like where we'll take from the range of some one
It is
number.
no. That was a range function, or range function is different, because in that
Okay,
range function is not to. I mean, how you will explain? Okay, a range function is something which will be defining your lower limit and upper limit, right? Here we have the lower limit, but out of these two options, one value will be fixed, which can be between 500 to 20,000. So one number will be there,
okay,
but that will keep on changing, because every time you will execute it, this random integer will generate a new value.
yes. So I
Uh,
printed number of pixels. It is just changing every time from 9,000, 8,000
the
random.
better way to deal with these type of thing is on the left hand, on the right hand side. Every time you wanted to check for individual functions, this is where you can try that, and you will see the value.
This kind of method where it is useful actually in image processing. Can you explain, please?
Which method? This generating noise image.
Yes, like white pepper, whatever, that white and
No, this
black or
is
spray type of.
basically, this is basically I am generating a problem, and solution will be discussed after this. This is, I mean,
Okay.
sometimes you'll have the scenario, right, that where your images will be full of noisy data, right?
Yes, yes,
So
yes.
how to deal with that? Before that, we should understand like how does a noisy image will be generated. So this is where I am generating the noisy image, and I'm gonna save it. So last thing in this, we will be storing image permanently, and in order to do that, I will write here cv2.write, or I am right instead, and I need to save this image on certain location. So I need to write some permanent location here. The opencv slash noisy image, maybe a name would be good, and pass here. This is the resultant, right? This is the resultant image. So the function returns me the noisy image. That's why we are passing the parameter image to the function, and function returns image, as you can see, which will be the noisy image, and that is the same image which I'm saving in the location. Now I'll save this.
So that 1500 and 20,000 is, it can be any number. I can change it because this is that indicates, I think,
The
density.
upper limit, yes, you can change it, but the upper limit should not exceed more than the number of pixels. Just take care of that thing.
Okay, okay, okay.
Otherwise, everything will be noisy. Okay, let me just share it in the last part. It's time to make your image, your noisy image go. Please save this image, and we have to use that saved image now. Import CV2, and I will be reading here the image and my image, which is noisy image.png. That's what I think I have saved. It is a noisy image.png. So I'll take here noisy image.png. You guys will also check where you have saved it. Please, while copy paste the code, please do not forget to change the path. Otherwise, you'll get an error. I'm hoping that you guys are making changes there. Please make the modification in the path. As I told you at the beginning of today's session, that please take any of the drive, C drive, D drive of your choice, and in that drive, create a folder named as OpenCV. That's where you will save all your programs, and that's where you will save all your images, resultant output, etc. even the videos and all. Otherwise, you will get an error.
Sir, which path we have saved? It is not saved. No, we didn't save, or it is by default it will save it.
No,
The noisy image.
we are saving here, no. But the path you have to provide according to your location. Don't copy paste my path while performing the copy paste. Usually, people don't forget it about that your path will be different from my path. Okay, let's read the noisy image. So please again change the path wherever you have saved that resultant image. And now I need to use the application of what we have learned here. That is the smoothing of the image. So I'll first start with this 2D conventional filter matrix, which we have generated here. This is your conventional, or you can say convolutional filter matrix from the CNN. Okay, so I just copy pasted the same thing. Image is there. Kernel is created. Second. Okay, kernel is created, and we have applied this kernel to my first image. Then Gaussian image, median blur, and average blur. We got here Gaussian blur, median blur, average blur, and we also removed the sharpened image as well. Cool. So smooth, Gaussian blur, median blur, and average blur. Let's try to apply all these together on my resultant noisy image, and let's see what happens. So this is my first result, which will be smoothed result. Then Gaussian blur, median blur, and average blur. Okay, execute. Okay, let me delete. I think the previous image might be there. And here are the resultants. This is a smooth. This is original image. This is median blur. This is Gaussian blur, and this is average blur. As of now, I will show you the comparison between. Okay, as of now, I'm just commenting the average blur. Please watch the screen. The blur looks too high for me. So what I'll do is I will change these numbers from high number to low odd numbers. So I'll go for lower, like 5 cross 5. This 9 I will change it to something like 3. This is median blur. Then this 9 cross 9 I'll change again to 5 cross 5. And let's execute it. What you will observe here, that the median blur has actually recasted your image compared to the others. Smoothed, Gaussian, original. Compare the original with your median blur. That's what the application is. Application is about eliminating the noise, and that is what these blurs are capable. When other blurs are reduced, they look a little more sharper, but the noise is not getting eliminated, isn't it? Only the median blur is capable of.
Which are saved. I think I don't know whether it is hidden or I'm unable to see in the folder. Can you just suggest what would have gone?
Wrong would have been the path.
I have given the same path. It is able to give display without any error. The entire code is running and it is displaying the code image. It is reading from the same path, and but while writing, it is not throwing any error. But when I check, it is showing the image with noise, everything. But once I close it, like I mean the destroying the windows, I'm unable to see the image which is written in that particular path.
No, I don't think so. This has to be there. How it is? There is no way that this is a possible thing. If I'll execute it, you will see that it is available and it is reading. I mean, earlier it was reading from the Apple, and I deleted the Apple. And this is where my images available. No? This is where my images are. Here, it's what I'm reading. So it will automatically come after the first code, that is this one, opencv underscore noisy. When you will execute it,
Yeah.
it will go to the path where whatever you have written here. So check what is the location here. That's where you will find your image. And once it is found, you please tell me, okay? Otherwise, I'll check what is the issue. I mean, okay, please speed up everybody and do it
Excuse me, sir.
fast. Yeah.
Excuse me, sir. Yeah. Actually, my that Spider got crashed, so I missed that point. You have given two parameters. Can you open your current
It's opened. Which
notepad?
where which question? Sorry,
Uh,
which file?
the latest one we were working, smoothing file.
Okay, latest one.
Yeah. Here the parameter 3 in median blur works is has what importance?
So wherever you are
And
seeing all these, right? These are the kernel shape. Assume it that the 3 pixels will be selected in a combination, and out of that 3, the middle term will be considered. Middle pixel value will be taken.
okay, okay. Because I gave 9 by mistake and the image was clear there at that. I mean clear in the sense all
No, it
the
is
noisy
clear
thing.
only if you will go for 5 also, it is fine. You can go for any odd number. But the
Okay.
problem with the 5 is that it is not sharp enough. So first you have to apply 5 and then you need to again apply the sharpening. Like 5 has removed all the noise, correct? But this is more
Mm,
blurred. It is not
mm.
sharp. But with 3, that's why I'm reducing with to 3 value. 3 is the lowest possible value. With 3, okay, I need to destroy all. With 3, you will see that your image looks quite sharp.
Correct,
With
correct. Yes. Yes, I got it. Thanks. So through our previous exercise, correct me if I'm wrong, we were trying to randomly make the image noisy. And here again, from every, suppose consecutively 3 pixels, we are correcting 1 pixel. So
hmm.
it is making our image again back to original one.
You can try on Jupyter Notebook. And you please change your sending option from private to everyone, because it comes as a hidden message to me. That is what happened whenever you send a message. I don't able to see it. Change it to everyone, just like the way you shared done. Those who are not able to get the options with dot and tab, then in that case, please use Jupyter IDE. There it will work 100%. Or I think I don't know if here it will work with. Let
Excuse
me
me,
try.
you're making a point. Shall
Okay. Next, can we see what in median blur kernel? That will be the resultant image. Median blur will be middle term. I guess in that case, no. Middle term will be different value for all the pixels. Say the 5 selected values are 220, 230, then 120, then 110, then 160. This is the 5 selected value. What will be the middle term in this? Middle term will be answer 120. So the selected kernel value will be 120 in that case. That's how the blur will be applied.
Or will it be average and then taking, because say
Average is
left side
also there.
pixel.
No? Average is average. Median blur will be middle term. Average is average here. There is an average which is by default cv2.blur. Anyway, we have this is how your blur will work. So median filter will basically filter out the basic. Remember that this median blur is using the filter. Okay, this is the filter size. So filter size is what? 5. So in this case, the middle term will be what? 120 from the first selected value. Okay, we are done here with this example. Let's just save it with opencv. And to all my opencv, we will be going with this. We can save it as smooth noise. Okay, let's do another example. This is the end of your median blur thing. Similarly, remember that average blur is also there, which will calculate the average of the selected matrix. Gaussian blur will calculate the Gaussian value from the selected matrix or selected region, and that's it. This is how it is working. and this was basically using this as a kernel shape. In this case only we have created our own kernel. In other cases, your kernel shape it needs to be provided. Only the kernel shape as we have provided. These are all kernel shape. Okay. We will talk about this in detail when we will go to the convolution neural network, that how exactly your resultant values are calculated. In a mathematical term, of course, I will explain you there. As of now, you understand that there is a matrix region which is selected and that is getting multiplied, and accordingly your kernel value is created.
Sir, one doubt. At right hand
Hmm.
side, that console. So we have 5 into 5 matrix. Is it that that the np.155, that one kernel?
Ah, correct. Yes, yes.
But actually, I am seeing in my system it is showing float values dot 0.1 0.11 like that. It is showing. There is no decimal number. It is.
Can you share the screen? I'm not understanding what you are exactly saying.
No, sir. Actually, I am working with other system parallelly.
Oh.
Sorry, I cannot say this. Here I am listening other system. Yeah.
Okay. Fine.
Actually, it is
No
showing
problem.
0.1111 like that.
Can you paste what you have? What is your code at the kernel side? What is the kernel? Is it same like this?
I will try.
Okay.
Okay.
Next example. Next example is about listening the external things like mouse click and something. So I'm gonna try the next example, which is gonna be about mouse clicks. This is gonna be my next example. Okay, let's begin with that. Okay, let me start here with the next example. As I told you, like I'll be working on mouse clicks. Import CV2. Import. No, NumPy is not needed. Counter value starts with 0. Mouse position will start with event, comma y, comma flags, comma parameters. Global counter. If event equals to CV2 dot event underscore. Now, when you will write again, you will see the options. What type of event listener you are creating. So we are having a lot of options like Alt key press, Control key press, left button, M button, right R button. Different button options are there. You will see here. I'm interested in even you can listen to the mouse wheels, mouse move, mouse uh, left button, mouse right button. So in this case, I'll simply write L button down. L button down here is an event that we are about to listen. And what is this basically going to track? It is going to track the left button click. This is a mouse click. Event is your left mouse. We got here. Go with my circles. Counter. Compare this to x comma y. Counter I will increment. I need the 4 value here. Now, circle is basically a matrix, which will be like an empty matrix, or with empty np dot zeros, or with the shape of 4 cross 2, numpy dot integer, cv2 dot imread. Time to read an image, which will be the cards image. Again, please take care of the path thing. This is my path. Your path could differ. cv2.imshow, cv2.set. Because we are trying to listen to the mouse button, so this function we need to write here. Set mouse callback. In this, you need to provide again the Name you have to write the same, which is original again. And this will return me the mouse position. So basically I will write here mouse position to get the position, to get the exact coordinate locations. 4 corners, that is what we are trying to look. Wait key delay will be 0 and cv2 dot. Let's try all the windows, we'll close all the frames. Now with that I will able to get this image. Now please look at here what I'm trying to do. I'm trying to get the coordinates of this particular card. 1, 2, 3, 4. So basically I clicked it 4 times, and this is where your matrix which we created here, a 4 cross 2, because each position will return me an x coordinate value and y coordinate value, and that is what is getting returned here. And when I'm clicking at the corners, the matrix, the positions, the click positions are getting filled here, and that's what I have printed. It's what exactly I printed here, the print circles. Make sense? Now you guys try it out. This is how you can do it. This is your another interesting example of,
Is there a way
yeah.
where we can? Is there a way where if I click on the particular portion of an image or position of an image, it will show the pixel coordinates on the image itself?
On the image will be, can be done, but then the code complication will be a little high. That's the only thing. I mean,
Okay.
you need to print over the image. We have
Means
the
so that
option of plt dot put text. So
put
through
text. Okay.
that it is done.
Yeah. Okay. I'll explore. Okay. Because if you are doing something like reading a digital CT image, we want to uh, repeatedly refer to a particular region of interest.
That is what I'm
So,
trying to create here. This is about
oh,
region of interest. We are moving towards region of interest only.
okay, sure. Thank you.
Sir, I have doubt.
Hmm.
Sir, in
Yeah,
that if I want to get more than 4 points, the NP zeros must be increased. Am I right, sir? We
we
have
need to
defined here.
increase this.
Yeah, 4 comma 2. We can give any number of values so that we
Hmm.
can get.
Yes, sir. Uh,
Yes, ma'am.
where we have attached image with the mouse click. I mean, if I start two windows,
Hmm.
two images,
One image will be
image.
there, no?
No, if I
Only one
start
image
two,
is there.
image show. No, if I start two, now you have done one. I
Hmm.
did two images. I started two images, and when I clicked on mouse, it. Achha, so this original is this? Original. I guess this is the
This
name
is
of the
what you
image.
need to make it same.
Correct. Yes. Thank you.
This is important here. You cannot
Yes,
keep
it is
both
attached to this
different.
image. Yeah.
Correct. This is how it is attached by the name of the frame. Okay. This I can see only 2 people have completed it. What about others? Couldn't see the responses. Do share your responses if it is done or not, so that we can speed up with these basics. This is all about mouse clicks and yeah, save it as mouse click. Once we are done with the mouse clicks here, we will move towards ROI, that is region of interest. I need to extract out from this image that position, this selected position that we have taken. That's what exactly I wanted to extract out here.
Instead of clicking, can we do it? Can we give it as an automatic values? Like the coordinate values are mentioned. With that, within that coordinates, suppose for example 10 comma 10, then 30 comma 30. Between 10 comma 10 and 30 comma 30, whatever the values are there, can we extract? Is it possible, sir? In the image, we are giving some
I
coordinate
understood
values.
your question. I'm thinking about that.
Yeah, yeah. Thank you.
I don't think so. Without how it is able to know that this is the region I wanted to extract unless we apply machine learning?
Okay, sir.
I don't think so. Clicking is the easy option right now because we are dealing with an ROI. To get that region comes under the part of image segmentation, and image segmentation is particularly a machine learning technique, a deep learning technique instead.
How many times are this set mouse callback is called whenever
Four
we
times.
click on the
Whenever,
mouse?
every time you will click, every time you will click.
Then when we write print statement inside that method, it is printing multiple times.
Because every time we are clicking, this is
No,
getting
not
called.
that print. Not that print. The one which is
This print
outside
circle is
event.
getting printed, no? The print circle,
No,
right?
extra print. I have added below global counter. If I add print, say params, what is coming in flags and params, I was not aware. So I thought of printing. So nothing is coming here, but it was printing for 100 times. I mean, many times. Even before clicking, this was getting called.
Maybe some what do you say? Some default value or something might be printed because in this case we are passing the event. This takes actually these coordinates, event name, x coordinate, y coordinate. Flag will be set to
I
minus
try.
1, and that's it. That's the only thing we are passing. Parameters are not even getting used. These are enough. Event is there, x is there, y is there. Even flag is not getting used anywhere.
Circles, it is showing undefined parameter. Is it?
No, no, circles is there, no? Okay, let me finish the things for today. So, as I was saying that, okay, instead, let's do it tomorrow only. We will talk about how to extract out that card from the image with the help of perspective transform. So, that will be the next thing.